This is CPE 233. This is lecture 20, example 1. And this is a classic example. It's kind of the register shift register problem. So let's just jump into it here. So this problem says what I'm going to do is every time I get an interrupt, I'm going to read a value from the switches, and then I'm going to output the value that I read 3 times ago to the LEDs. Now the issue is that the notion is I have to remember those other values, and that's the key to this problem. I get an interrupt, read the switches, write the LEDs, but I'm writing the value that I received 2 interrupts ago. And so this is a classic problem where I've got to have, essentially got to have 3 registers here, and I think I call them X20, X21, X22. So when I get an interrupt, I'm going to read a new value into this register, which means this shouldn't have a valid value. Also, when I get an interrupt, I'm going to output this value to the LEDs. Step 1. Okay, step 1, this is step 2. And the last step is to copy this data here and this data here, and not in that order. So we'll say 3 and then 4. And these are, once again, these are just register values. And that's the way I'm going to do this problem. Now this is a classic, that's the meat of the problem. I don't really want to do a flowchart because the flowchart is very similar to the previous one. And it's very straightforward. Plus, we are going to work off our cheat code here. Now this code is going to be, is our baseline interrupt value or interrupt program that I use as a starting point all the time, and it's gonna help us crank this problem out really fast. So let's go ahead and do that. I'm going to switch over to RARS now. Okay, so here we are back in RARS, and this is my interrupt template program. I'm just going to modify real fast. Let's crank through this, see how fast we can do it. And this is the, we'll leave that here. I know this is the, this is one of the addresses. This is the LED address. Heck, I don't even remember. Let's look at the problem again. Okay, according to the problem, this is the LED address. And this is, let's see what we got here. And this is the switches, according to the problem. So we'll write that down. Okay, and that's good. So those we're going to use those later. Next thing we want to do here is on these lines is write the address of the interrupt service stream into the MTVEC registers. That's standard stuff. That's all good. I am going to use a flag on this one, like we usually do. That looks good. So I'm hitting the flag value. I don't have a count value, but I do need to do 2 other things on this thing, and that was the problem stated that I don't need to write anything. I guess I could, but problem didn't call for it, but that's good. So what I'm going to do here is I'm going to use that register X21 and X22 as kind of registers with valid data in them. So what I want to do is start those off at 0. And I'm just going to clear and clear. And additionally, I shouldn't have done that. That's okay. And we'll set this up here. Darn. And let's clear these 2 registers. But what I need to do on this thing is start that start that flag at 0. So move, I think it's X8, X8, X 0. Okay, there's some initialization there. Last thing I need to do in this program is turn the interrupts on, and that's what's done quite nicely in these lines here. Home, let's see, guess it doesn't work. So here's where I'm unmasking the interrupts. Here's my tight loop here. I don't need that instruction. I can keep it just one instruction. And when I get an interrupt, it's going to break out of this tight loop right here. So let's look at the interrupt service routine. I'm setting the flag. I want to return from this with the interrupts disabled, so I'm clearing the MPIE bit, which I'm doing with this instruction. There's my clear instruction. So I didn't have to modify the ISR at all. And so what else do we have here is this is one, I'm clearing the flag bit, and then I'm re-enabling the interrupts, and then I'm jumping back to our polling loop. So most of this is done, really. The only thing we need to do in this program is to modify the interior of the program. So I don't really know what to do on this yet, but first thing we need to do is get the new value. So that's load word, and we'll put it in X. It's going to go in X20, and the address is the switch address, which is X16, and we'll say get switch data. Okay, so once I have the switch data, next thing I want to do is output the LED data. I can maybe say half. Well, I'll just keep it. We didn't really tell how many switches there are. I'm storing with essentially what I'm outputting is the value in X22, which we've decided was our maximum value, and this goes out to X15. Now you'll see what we're going to do is set this up such that X22 is the oldest value. Output older switch data. Okay, so that's most of it. And now what we need to do is move X21, X20 to X. I always get these backwards. Now X20. You got to get this. You got to get the order right in this one. X22 gets X21, and this is transfer the value, and then I'm going to do the same thing. X21 gets X20. Okay, and I'll just say okay, and I think that's it. This is all setups to be done after that, and I'm going to call this problem done. Now, once again, I did more copying and pasting than I did writing this thing. The only actual really super meaningful code I changed was in here, although I did add 2 initializations of these registers. Okay, so once again, I'm going to get, once I get an interrupt, four things are going to happen. I'm going to output, I'm going to get the new value, I'm going to output the latest value, and then I'm going to shift those 2 other values around. And that's it, folks.